equals 500,000 minus 100,000. That's the loan amount. Okay, and I is 0.5% per month. N equals once per month for 4 years. Okay, so payment equals A equals P times A over P using 0.5% and 48. And P is 400,000. On the test, you'll have this formula sheet, and I'll give you a photocopy of this, the whole appendix, all the tables. But I want you to hand those back because we were using them every time. Okay, so 0.5%, A over P, and we want 48. 0.235. That's 9,400. Part B is using 10% for the MARR, calculate the present value. Okay, so if I haven't stressed this before, I'll stress it now. This sometimes occurs. Remember, we talked about using the cost of borrowed money as your MARR. Well, if you have a cost of borrowed money and you also have a different figure for the MARR, 10%, like here, then you first calculate the payment using whatever the loan rate is, and then you plug that payment into your cash flow and use the MARR to solve present value. And that's exactly what we're doing right here. So we have 4 years. It's not a very straight line, sorry. And we know that monthly net equals 25,000 minus 9,400. The income minus the expense. So that's going to be 15,600. So we're taking our income and subtracting our payment, and that's how much we bring in net each month. And then the price is 500,000. Notice I'm using wrong. Notice I'm using 100,000 there because the 400,000 is included in the payment, and the payment is subtracted from 25,000. So, but we laid out $100,000 cash up front as a down payment. That's what this is right here. And then, salvage is 75,000. Okay, so NPW. It's gonna be 15,600, that's an annuity. A times P over A, 0.5%, 48. Plus the salvage. That's a future, single future amount F times P over F, 0.5%, 48. Minus the 100,000 is right now, so it's just minus 100,000. Okay, so P over A, 0.5%, 48. There's 0.5%. P over A, 48. Down, down, down to 48. It's 42.580. Remember, we looked up A over P. It was 0.235, so 1 over that is, and vice versa. Okay, but you have the table, you can just look it up again, or you can, if you realize that they're inverses, you can just invert it. P over F, 0.5%, 48, 7871. And now we just multiply and add, and that gives us our final answer. $15,600 times 42.58. Plus 75,000 times 7871 minus 100,000. 623,281. Okay, so 2 steps: calculate the payment, incorporate the payment into your monthly income, which is 25 minus the payment, 15,600 for 48 months. Plug that into your cash flow plus the salvage plus the down payment. And then figure out the present worth. So what questions do you have on that?
Did we not use the 10% of the MARR?
Oh, thank you. Yeah. I don't know if everybody heard that. I didn't switch over to 10%. I stuck with a half. So 10% over 12 isn't on the table. I'm gonna change that so that you don't have to use the formulas, because that's time consuming. I mean, you're welcome to use the formulas, but you know, in the interest of time, you probably want to use the tables unless you really like the formulas. Okay, so I'm going to change that, and we're going to use 12. And on the test, if I give you a monthly interest rate, I promise it'll be divisible by 12. So there won't be any weird interest rate on there. Okay, so thank you for pointing that out. So 12% over 12 is 1%. Right here. I equals 12% over 12 equals 1%. So I won't, like something like 10 or 11 that doesn't divide evenly by 12, I won't do that to you. Okay, so that way you can use the formula if you want to, but if you want to use the table, you have that option. I'm sorry, did you say something? I thought I heard a comment already, okay, so,
That would
let's-
change our answer for number A then too,
Yes,
right?
it will. Well, no, it won't change it for A, it'll change it for B. Because the loan is at 6%. Okay, so, P over A for 48 periods on the 1% table. 1% P over A, 48, 37.974. And now they won't be reciprocals because we're using a different percent, so don't try that. Okay, so, P over F, this won't be a reciprocal of that because of a different percentage. So, P over F, 48 is 6203. Okay, so I'm gonna re-multiply that. So now we get 538,920. Any other comments or observations on this? Okay, let's try the next one. When you retire from your career, period 0, so you just turned 65 and quit your job, you'll withdraw 1.5 million for buying a house and car and all the stuff, moving and all the stuff you have to do to set up in your new retirement home, 1.5 million. Okay, starting in the next month, period 1, you'll withdraw 5,000 per month for living expenses each month for 30 years. So that's 1 through 360. Assume that your monthly living expenses will increase by $25 per month every month. 5,000 first month, 5,025 the second month, etc. Your unused funds will remain in the account as you go through your retirement. Your retirement account pays 3%. Okay, and it's monthly compounding. So I'll make sure I add that. It's implied, but it's not specified. So I will make sure that I specify it. Okay, so part A. $30 years, once per month. You need 1.5 million right now. And then you need $5,000 per month. And 25 per month more each month. Okay, so the question is, what's the present value of that? Because that's how much money you need to have in your retirement account when you quit. Did you have I thought I heard a question, okay. If I don't tune in on, if you have a question I don't tune in on, you just speak louder, because sometimes I can, would be clueless. So speak louder if I don't acknowledge you. Okay, so, NPW, and in this case, it's all cost, so if we wanna not put all the minus signs, we can say PWC is 1.5 million plus A times P over A plus G times P over G. That's the basic setup. Okay, so equals 1.5 million plus 5,000 3% over 12 is a 1/4%. Okay, so we need P over A and P over G for 360 periods. 1/4% P over A, all the way down to 360 is the next to the last row. It's 237.191. And that's P over A 1/4%, 360, and P over G 1/4%, 360. So 1/4% P over G 360 is 36,000. That's pretty good. 263.93. $36,263.93. So that's 3,592,000. $553. Okay, so that's what you need in your retirement account when you hit 65. If that's your standard of living for the next 30 years. $5,000 per month is $60,000 per year, right? So plus your Social Security is a couple thousand a month. So if you already own a nice home, that's fairly comfortable. So Part B. Each month during your career, you're going to save to hit 3.592 million. You're going to work for 40 years, and it's 480. Assume monthly compounding, 6% in your savings. I mentioned this back during lecture when we talked about this sort of problem. You're a little more aggressive when you're saving because you want it to grow, but then once you retire, you don't want to be risky. You don't want to lose your retirement and go to the courthouse. So you shift it over to something safer, pays lower interest. That's why there's a higher interest rate when you're saving than after you retire. Okay, so what does A equal? Knowing that F is 3,592,553. Now, when I'm grading the test, if I give you a problem in two parts like this, and part one's answer plugs into part two. If your answer for part one is wrong, but you do part two correctly, except that this number is wrong, I'll still give you most of your points. So, I won't just mark the whole thing off if that number is not right. And so, A equals E, or F, pardon me, times A over F, I equals 6% over 12 equals 0.5%. So A over F, 0.5%, 480 equals 3,592,553 times 0.5%, we need A over F. All the way down to the last row is 480. 0.00050. $1,796 per month. So once again, if, let's say that I ask you something similar to this, and you pretty much set it up right, but you screw it up a little bit, this number's not right. So you get some of your points for that. And then if you plug the wrong answer in here and did all this right, you get probably most or almost all of your points for that part. Go ahead.
Just to be clear, we took the 6% in the problem and we divided that by 12 to get our 0.5% interest rate.
Yeah.
Okay.
Could be.
Okay, last one. Your town's gonna build a sewage treatment plant, costs $25 million up front. Annual maintenance is $500,000. Once every 20 years, you have to refurbish the plant at a cost of $5 million, starting at the end of year 20. Annual maintenance and periodic refurbishment will continue indefinitely into the future, so N is infinity. And so using an interest rate of 4%, calculate the capitalized cost.
Now, is that annual compound as well?
Yeah, this one's annual. Okay, so 25 million right now. And then starting in year 20 and every 20th year thereafter is 5 million. And every year is 500,000. Okay. So remember, our basic formula is that P equals A over I. But we need to figure out what A is. I is 4%. But we need to figure out A. Okay, so EUAC, uniform annual cost, equals 500,000. I should mention plus P, 25 million. Okay, so we don't need to find the annual value of that because they're asking us for P, and that part's already P. So don't try to make P because it's already P, right? So, but this stuff we need to find A. Okay, so 500,000. And then 5 million every 20th year. Remember, when that happens for infinity, the annual value of the first 20 years is the annual value for ever and ever and ever. So, and that's the key to solving this. The annual value for a single cycle of a periodic cost equals the annual value forever. I know I've said that like 10 times, but repetition is good for things like that. So, equals 500,000. 5 million occurs for the first time at the end of the 20 years. So that's F. Times A over F, 4%, 20. Okay, so 4%, A over F, 20, 0.336. So that's 668,000. Okay, so it's not confusing to say P equals this plus P. I'll say capitalized cost, which includes both the purchase price and the annual value. In other words, we're talking about two different P's, the entire P versus just the money up front. But to avoid calling them both P in the formula, okay, so the capitalized cost was A over I plus P equals 668,000 over 0.04 plus 25 million. So that's 41,700,000. whole thing. It's gonna be 3 problems. They won't be exactly like this, but they'll be pretty close. Go ahead.
So we don't have to do anything, for the $500,000 for the annual maintenance, we don't have to calculate anything for that.
We do, it's right here.
But I mean, we just plug in 500,000.
The annual cost,
We don't need to like, since it's core. We don't need to calculate 4% or anything.
no, just because that dumb thing I always say, if I tell you A and ask you A, don't try to make it A because it's already A. It's already, if I ask you what's the annual cost of something that costs 500,000 every year, it's 500,000.
Okay.
That's,
I'm just like, getting it confused with like other problems that we had with work, like trying to.
okay. But the 5 million is only once every 20 years, starting at year 20. So that's why we did that part right there.
Okay.
So when we're finding EUAC, it's just only at one point in time, like at one annual year.
EUAC is the annual equivalent. So it's $668,000 every year.
So that's
That's
putting
equal
the,
to, that's equal to 500,000 per year plus 5 million every 20th year.
okay, that's
If
just,
you stretch that out annually forever, it's 668,000 or per year. Does that make sense?
Instead of spending $5 million at every 20 years, he's calculating.
that's what it would be if it was,
Spending it every year as you go.
yeah, okay.
This, excluding the 25 million that I just covered up on my finger, the rest of this is equal to,
Yeah.
that. I think that was your original question, was, is it a single point in time? No, it's every year forever.
Yeah, okay, yeah.
Does that make sense? Or did I not answer your question?
No, that answered my question. What I meant was, that's going to be the, like, almost like average cost at each point in time, but it makes
Yes.
sense.
Yeah.
Yeah.
So will we be given the present, like in this case for this problem, we're given 25 million? On the test, will we see the problem similar to this, or will we be given the future value and have to determine the present?
My